Good morning everyone, especially to you Ma'am Kyle. I'm Angel Moredo together with my co-members Ibanez, Pableo, and Awami. Our topic is Invariant Principle, which is under Unit 4. And today, I'll be discussing the definition of the Invariant Principle and its two main categories. So, what is invariant? First, the word invariant just means never changing. That's really the main idea. In math, it means there's something like a number or value that stays the same even if you keep doing the same kind of move or transformation again and again. For example, let's say we have a group of 2 coins, 2 for heads and 2 for tails, and every time we're allowed to flip 2 coins at once, no matter how many times we do that, the total number of heads and tails might change. But the difference between heads and tails will always be even, and that's an invariant principle. It stays the same even if we keep doing the same action. So if ever we end up with 3 heads and 1 tail, we'll know there's something wrong because that breaks the invariant. It's actually a way to prove that some situations are not possible. So even if this idea sounds tricky, it's very useful because it helps us solve problems and know what is possible or impossible just by checking what stays the same. So there are basically 2 main categories, which is the invariants and monovariants. First, invariance, a property that stays constant. This is when a certain value or property stays constant all throughout, like in the coins example. If the difference between heads and tails stays the same, no matter how many flips we do, then that's invariance. Second is monovariance, a property that only changes in one direction. This is when a value only changes in one direction. It either always increases or always decreases, but it doesn't go back and forth. For example, imagine you have 10 candies. Every time you eat 1 candy, the number of candies decreases by 1. You can keep eating candies forever, so you have 0 candies left and the process stops. And that's what we call the monovariance. It helps us prove that something will eventually stop or come to an end. So, some parts about how it works and its importance and some additional example with computation will discuss by my co-members to help you understand the 2 main categories.
Good day everyone, I am Angel Ibanez from BSN Math 2A. For my assigned topic, let's discuss about how the invariant principle works and its importance. So the invariant principle works by identifying a property or quantity that remains unchanged throughout a series of transformations or operations in a problem, and its importance lies in simplifying complex problems by providing a stable reference point, allowing us to deduce properties of the final state. So we have here the 3 steps of invariant principle. The first one is identify the invariant. So find a property, quantity, or relationship that remains constant despite the changes. So this often requires careful observation and understanding of the problem's dynamic. The second one, we have proved the invariance. Rigorously demonstrate that the identified property indeed remains constant under the given operation. So this step is crucial to ensure the validity of the approach. The last one, we have the apply the invariant. Use the invariant to constrain the possible solutions. Prove that certain outcomes are impossible or directly calculate the solution. By focusing on what remains constant, the invariant principle provides a powerful tool for understanding and solving a wide range of problems. Its importance is underscored by its ability to transform seemingly intractable problems into manageable ones by shifting the focus from the changing element to the unchanging core. So that's for my part. Thank you.
Hi there, I'm Kay, and let us talk about one of the examples of invariance principle.
Imagine an 8x8 chessboard. It has 64 squares, and like a normal chessboard, the colors alternate, black and green. So there are 32 black squares and 32 green squares. Now, let's remove 2 opposite corners of the board. If you look closely, you'll see that both these corners are the same color. Say both are green. So after removing them, we now have 32 black squares, 30 green squares. Now comes the key part. A domino is a piece that covers exactly 2 squares. Because of the alternating color pattern, each domino will always cover 1 black and 1 green square when placed on the board. This means for every domino we place, we remove 1 black and 1 green square from the board. But now we have an imbalance. There are 2 more black squares than green ones. So it's impossible to pair up all black squares with green squares using dominoes. No matter how hard you try, you'll always have 2 black squares left over, which can't be covered by dominoes without overlapping or going off the board. That is why it's impossible to cover this modified board completely with 1x2 dominoes.
The invariance in here is that each dominoes will always cover 1 black and 1 green square, because that's the unchangeable condition. No matter how you try, the condition won't change. So that is the invariance principle.
Hi everyone, so my name is Jamaica Sinawang. So today I will be tackle the monovariance. So here we have our example of monovariance. So suppose you have a positive integer. So what are the positive integers? Those are number 1, 2, 3, 4, 5, so on and so forth. So now do not include the negative numbers, zero, fraction, and decimals. We are now allowed to do the operation. So if the number is even, divided it by 2. So first, what are the even numbers? So even numbers are those 2, 4, 6, 8, 10, 12, and so forth and so on. So those numbers that can be divisible by 2. So next is, if number is odd, subtract it by 1. So what are the odds numbers again? So those are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19, and so on and so forth. So those even numbers that cannot be divisible by 2's. So the claim here is, no matter the starting positive integer, the number will eventually reach to 0. So means whatever the positive integer we put or we start at the end or eventually the numbers will still be 0. So monovariance use. So what are the monovariance use? So we define the monovariant as the value of the integer itself. So if the number is odd, the subtracting 1 makes it decrease. So bumababa yung value ng number. So if the number is even, the even number dividing by 2 still makes it decrease unless by it's already 0. So kahit i-divide mo yan siya by 2 or kahit malaki yung number na dun, basta i-divide mo siya by 2, yung value nun is bumababa pa rin. Since the integer strictly decreases at the every step and can't be go below 0, eventually it must become 0. So kahit anong gawin mo dun sa number na yun, sa value na yun, magiging 0 pa rin siya. So if we start with some number, we all keep reducing it with certain rules, and we want to prove it eventually reach to 0. So the rules are here. If the number is odd, subtract 1. So like for example, 7 minus 6 is equal to 1. So this decrease the number by 1 kasi may minus naman siya, diba? Na-subtract na. So next is, if the number is even, divide it by 2. So like for example, 6 divided by 3, yung lalabas dun is 2. So this also decrease the number. So napapansin niyo, bumababa talaga yung value or yung answer ng number, kahit even siya or odd. So in the situation where we can use monovariance are like in the mathematics, computer science, and puzzle. So that's it.